Okay, so let's do this. This needs to go away somewhere. Can this go somewhere else? I don't know. I'll throw that over there. Okay. Okay. Angles in any position means terminal arm. So it could be anywhere in the 4 quadrants. So that means I could have an angle in quadrant 2, an angle in quadrant 3, and we kind of did that with reference angles. So you guys have seen this before. Am I too loud at home? Am I good? I was cranked up yesterday because I was on my Mac.
It's good.
Okay. All right, and again, quadrant 1. So this is a nice little chart. Ooh, I got a lag here. I'm watching my screen and it's a little laggy. Okay, I'm just gonna go. So in quadrant 1, notice that it's got a coordinate pair that says plus minus. So what that means is your x coordinate is positive, your y coordinate is positive. In quadrant 2, your x coordinate is negative, your y coordinate is positive. Okay, I'm just gonna look at the sheet because I can't look at the video because I keep, when you're in quadrant 3, your x is negative, your y is negative. I'm looking at the video, geez Louise. In quadrant 4, your x is positive, but your y is negative. So that's what all those like little brackets mean. It just means, is your x coordinate positive or negative, y coordinate positive or negative. Okay, so here we go. And you guys remember your trig formulas? So sine theta is equal to opposite over hypotenuse. Cos theta is equal to adjacent over your hypotenuse, and tan theta is opposite over adjacent. Right? We remember that? Yeah, we talked about it. Yeah. We talked about it on Tuesday. Yes. Years. Eons. You guys are so old. Also, they're at the back of the room on the board. They're also on your formula sheet. So these you use with right angle trig. So these only get used with right angle triangles. So those are the only thing that we use with right angle triangles. They can't be used with a non-right angle triangle. Okay, so here's the thing. 2-1 and 2-2 are preparing you for the unit circle in grade 12. So they're kind of like connected together and they deal with right angle triangles. And then 2.3, we're going to deal with non-right angle triangles. It's like a whole different trig unit, but because it's still trig, we mushed it all together. But they're 2 totally separate things. Danica, who are you texting? That's more important than us. You still didn't tell me who you were texting? Okay, doesn't matter. Fair. Okay, if your point is in quadrant 1, what are the sine, cosine, and tangent ratios? Okay, so let's do some math here. Somebody give me a coordinate of a point in quadrant 1. No, give me something better than that.
5 and 6.
5 and 6. I like 5 and 6. Normally, 1 and 1 is a great one. So you guys would agree that that maybe is around 5 and 6. You guys would agree with that? Yeah. Okay, so now let's draw a triangle based on that point. So we're going to connect it from the origin to the point, and then we're going to draw our vertical line in, and then obviously our horizontal line. So you guys would agree that that's a right angle triangle? With my right angle being right there? Looks pretty right to you. Now the angle we're always measuring is at the origin. Okay, so we are always trying to find that angle. All right, so if you know the point is 5, 6, you know something about that triangle already. What is the height of the triangle? 6. What is the base length of that triangle? 5. What's the hypotenuse of that triangle? Could we find it? Yes. What are we going to do? We have no angles, but we have two sides. So what are we going to use? Pythagoras. Right. So we're going to have a squared plus b squared equals c squared. So 5 squared plus 6 squared equals c squared. So 25 plus 36 equals c squared. So we're going to have 61 equals c squared. And so I'm going to square root both sides. So c is equal to the root of 61. Okay, that's not a nice number, but we'll go with it. Did I screw it up?
No, how do you do,
How do I do what?
like put it in,
Okay, so what I want you to do is it's asking for the sine, cosine, and tan, but the key word here is ratios. So I'm not asking you to solve for the angle. I'm asking you to state the ratio. And the ratio is just that fraction. Okay? So we got to do 3 of them. We're going to do the sine fraction, we're going to do the cosine fraction, and we're going to do the tan fraction. We're not going to do any math, so we don't need our calculators. We're just going to go ahead and do those. Okay, so sine of the angle, and I said my angle was right there, is equal to, so which one's the opposite side? 6. Maybe that's a good idea that we label these. Hypotenuse? Root 61 is our hypotenuse. And 5, what side is that? It's the only one that's left. The adjacent. I find that it's helpful to label my sides. I'm usually zoomed in so much better. Like I said, power outages are no fun for technology. I usually label my sides before I do my trig ratios, just because to me it's easier to see them. Okay, so sine is opposite over hypotenuse. So we're going to write 6 over root 61. It is. You can rationalize the denominator. You do not have to, though. So cos of theta is going to be 5 over root 61. And tan of theta is equal to 6 over 5. Ooh, I was going to put root 5. Don't know where that came from. Okay, so pretty simple, right? Super simple. What do you, no, we'll get to that later. Okay, never mind. Okay, let's go into quadrant numero 2. So that you have listed the sine, cosine, and tangent ratios. When I ask for a ratio, I want you to set it up like this. This here is the ratio. Don't solve it. This is the ratio, okay? Because I'm going to ask you to do that. Magnus, do you not have your notes with you? Okay, all right. You just look like you're like ready to like, you're just super into this. So into it that, no, he's awake. Okay, so now we're going to have a point in quadrant 2. Okay, pick a point in quadrant 2. -4 and 2. So -4, +2. So right out here. I'm really proud of you guys that you know what quadrants you're in and what the coordinates would be. So again, we're going to make that right angle triangle. So we're going to connect the origin to our point. Vertical line, horizontal line. There's my right angle. What do we know about the height of this triangle? The height should be 2, and the base of the triangle is going to be -4. -4, because you're in quadrant 2. But remember that we are on a coordinate plane, so by the negative, it's just telling us we're going 4 to the left from the origin.
It's just telling you directly.
Pardon?
If you're finding sine, you still go -4.
Okay, we're going to get there. We're going to get there. Yes, you do. Yes, you do. And then no, you don't. Yeah. You do and then you don't. Just go with me on this one, everybody. It's gonna be great. Everybody's gonna love
That
this.
sounds like famous last words.
It is kind of famous last words. You do and you don't. So you gotta you gotta trust the process here. What's my hypotenuse? What's my hypotenuse? So 2 squared plus negative 4 squared. Please notice that I put the negative 4 in brackets because I want that. I want the negative 4 to be times by negative 4.
So shouldn't the negative be removed from most of the time through the equation? Like if you're like going like one direction, shouldn't this remove the negative?
No, don't remove the negative.
Well, not that. So like with like squaring it, it gets rid of the negative.
Okay, that's a good point. You notice something. Hey, can we simplify that? Yeah.
Yes.
I don't remember my whole thing.
Oh, that. Now we're getting to it.
Okay. Do you guys remember how to do that? That was chapter 5, right? I did that all in one step and I didn't even I had no baby steps. Like there was no training wheels on that. I just jumped right into it. What are the factors of 20? 4 and 5. So I'm going to take the square root of 4, which gives me 2. And square root 5 doesn't work very nicely, so I leave it as square root 5. So that's simplifying radicals from chapter 5. Yay. So this is...
Simplifying radicals. That's Danika's favorite, Miss Galley.
I'm pretty sure it is. I'm pretty
Yeah.
sure it is. So remember that theta is always made with the origin. And now I'm going to go ahead and label my sides. So this is my adjacent. This is my opposite. This is my hypotenuse. Jacob made a statement and I kind of brushed over it, and I don't know if in class people heard it, but at home people definitely didn't hear it. But he said, when you're doing the squaring, isn't that always going to get rid of a negative number? And he's absolutely right. Your hypotenuse should always be a positive number. If it's a negative number, you've done something mathematically wrong. Okay? Okay, so let's do our ratios again. So sine of theta is equal to 2 over 2 root 5. Can we simplify that? Yep. That's exciting. It really is. But it's so cool that you guys know this stuff now. Can we reduce that one? Yes. I'm skipping all kinds of steps. Can I reduce that one?
Yes.
Yes.
How does that top would even work? That's actually honestly.
Did any of you lose your theta in these? Look at your page. Did you lose your theta?
I put theta after I've done the math. Is that
Don't lose your theta. That's going to deduct 2 points. And you know what the sad thing is that when we're only dealing with such a little amount of points, if I take off a full mark because you lost your theta or you didn't simplify, that really doesn't have a ton to do with the math. That has to do more with the mathematical grammar. I don't know if that's a better way to say it. Okay, so we're good with that? Okay.
but 1 is more than 2. That's the answer.
What I don't hear what you're saying, Xander. What are you saying?
The negative 1 over 2. That's not work.
I don't understand. What doesn't work? We were just writing it as a fraction.
If you were to do the math though to get the thing, would that not work?
If you're doing the math to get the thing, you're starting to sound like me.
So,
So you do the math. Just do the math, Scallion. So you're asking me if I solve the angle?
yeah.
Do it in your calculator. So Jacob, wrong person, right row, wrong person. So Xander is saying that's not going to work if I put that in my calculator. So I'm solving for an angle, so I'm going to go second function tan. Am I doing tan? -1 divided by 2 gives me a negative angle. That's weird.
Okay, I'm not crazy, thank God.
Well, it works. Negative angles are fine.
Come on,
Welcome to grade 12, negative angles.
wouldn't that just be going like,
So how do we measure angles? We start at the positive x and we go this way, right? We go counterclockwise. Everybody with me? That's a positive angle. A negative angle is going to start at the positive x, but it's going to go in a clockwise direction. It's super exciting. You guys are like advanced past triangles now, and now you're on a coordinate plane, and it's super fun. Okay, let's keep going with this. Quadrant 3. We're going to pick it up the pace a little bit. What's a point in quadrant 3? -3, -4. I like it. So -3, -4 for the record. My points are getting less accurate in location and more about can I fit my triangle in there. So drawing my triangle.
I mean, technically, it depends on how you draw your graph. Like,
True. Remember that theta is always at the origin. So I guess this time my depth of the triangle is going to be -4 and my base length will be -3. So let's see if we can do it in our heads, ladies and gentlemen. What is the length of the hypotenuse? Do it in your head. See if you can do Pythagorean theorem in your head.
27.
It's 5.
She's right.
Oh,
Do it in your head. Everybody just,
I did the math.
okay, think for a second.
It is fine.
It was fine.
Okay, so take a minute, think about it in your head. It's hard when people are all processing faster, but I drop the negative right away when I'm doing it in my head. Okay, I got 3 squared, that's 9. 9 plus 16 is 25. The square root of 25 is 5. And we know the hypotenuse is always positive. Okay, all right, that's good, everybody. Yeah, that's good.
do we have to show us the?
I'm going to tell you that that's a Pythagorean triple. And that's a well-known Pythagorean triple. And so what that means is that all the numbers work out nicely. You don't have root 61 or something like that. So we call those Pythagorean triples. So 3, 4, 5. If you know it, use it. You don't have to show it to me. Okay? 12, 13, 5 is another one. But it's 5, 12, 13. 25, 144 is 169. Square root of 169 is 13. So 5, 12, 13 is a Pythagorean triple. Just there you go. So let's do our ratios. So sine theta. Oh, I didn't label. I'm just so excited. Hypotenuse, opposite, adjacent. So sine is going to be -4 over +5. Can't reduce that, so those are nice. Then I got a -3 over 5. Can't reduce that. And then tangent, I have a -4 over a -3. Now, would I leave it like that?
No, you get rid of the negative.
I'd get rid of the negatives. I don't want anyone to leave it with 2 negatives in it because that's just like bad math grammar. You guys okay if I just go in and erase those? Okay. Okay, quadrant 4, last quadrant. What's a point in quadrant 4?
8.
Okay. You guys like to challenge me. Okay, 5 and -4. So
Why don't we apply since
did we do 5 and 4 already? I don't think we did.
you do -4, 5?
Okay, so can you do it in your head?
Yes.
Okay, do it in your head. Well, we did do this one before, you're right, yeah. So hopefully you can do it in your head.
You never had some quick ones.
Didn't we? Oh, did we do 6?
No, we
did
did
say.
5 and 6.
Oh, okay. I knew we did 5 and something. Okay, do you guys got it? It's a bad number, that's fine. We're good with bad numbers. What is it? Root 41. You have to be kind of exact in this one. So I did well, Danica did it in her head and I just copied down what she said. So again, like Pythagorean theorem isn't something that I'm giving you, like knowing how to do Pythagorean theorem is something that you learn in grade 8. You need the correct number though to do the grade 11 outcome. Does that make sense to everybody? So you don't need to show me this, but this needs to be perfect. That's a lot of pressure. So sine theta, ooh, I'm not gonna label this one, I'm just gonna do it. Sine theta. I'm waiting.
-4 over square root of 41.
Beauty. -4 over root 41. Cos theta. 5 over root 41. And tan theta is -4 over 5. I always do them in this order. I always go sine, cosine, tangent. I always do it that way. And like other people do them in like random orders and it stresses me out. But you do it in the way that makes the most sense to you, but this makes the most sense to me. Okay, so the bottom of this is called the cast rule. It's not very exciting, but it's going to tell us what ratio is positive in what quadrant. So okay, so the cast rule tells us what ratio is positive where on this coordinate plane. So going back to page 1, what ratio is positive in quadrant 1? All of them. Okay, in quadrant 2, what ratio is positive? Go, I'm talking about the ratios, sine, cosine, or tan. Sine is. In quadrant 3, that is up at the top of this page. This time, which one's positive? It's tangent, right? Mm-hmm. Anybody want to hedge a bet without even looking? What's positive in quadrant 4? Cosine. So this is why it's called it the cast rule, C-A-S-T. We call it the cast rule so that I know quickly in what quadrant what ratio is positive. Okay? It's super fun. Kind of. Okay, you need to know that. You need to memorize the cast rule. I wouldn't get a tattoo of it because you need to leave more real estate for better tattoos. The unit circle is going to be what you should put on your forearm. So far, nobody's taken me up on it. Okay, so we're going to use our reference angle to solve for theta. That's a really little tiny theta. You use your reference angle to solve a simple right angle triangle because we're all really good at that. We know how to do it. It's grade 10. We can solve right angle triangles, no problem. With a positive degree measurement, use the cast rule to determine in what quadrant your point is in. Okay, so we kind of found this out. We found this stuff out on Tuesday that theta is in quadrant 1, theta is the exact same as theta reference. That was that question 3, part C, the 72 angle one, right? It's always the acute angle. This was, you guys did these questions. This one here. This question here was the question you asked me about. What's the reference angle for 72? And the answer is 72,
Okay.
right? Because it's an acute angle and it's in the first quadrant. So when I get to here, we know that in quadrant 1, theta is theta reference. They're the exact same thing. To solve it for quadrant 2, you did this already. You know your straight line measurement is 180. If you know what your theta reference is, you can subtract it from 180 and you find the original theta. You guys did this in 2.1. Do you guys remember that? Like, so in quadrant 2, if I have this and I know that there's my real angle and my reference angle in here, let's say is 30 degrees, what's my real angle? 150, right? Because we're taking our reference angle, we're subtracting it from 180, and that tells us our angle in standard position. This right here, that's theta reference, theta r. Okay, so if we're going to do in quadrant 3, this one was the weird one, right? Because that's my real angle, but we know theta reference occurs in there. So that was the one where we had to add it. We had to take the 180 and add in what our theta reference was. That's what we did in 2.1. Quadrant 3 was the weird one. And then in quadrant 4, if we know that this is theta reference, we know our standard angle is that there. We know that the whole thing is 360, so if we just take 360 and minus theta reference from it, we'll get our angle in standard position, right? So that's 2.1. You guys knew all these rules, but they're actually like mathematical rules. But you guys figured that out without knowing the rule. Okay? All right, here we go. Okay, everybody take a deep breath. All right, the point, negative 512, lies on the terminal arm of angle theta in standard position. Determine the exact values of sine, cosine, and tangent. So exact values, I want ratios with no decimals. Fractions, radicals, right? Like we don't want to move anything to decimals. So my question is where is this point? What quadrant is this point in? 3. All right. So everybody drop that into 3. And you don't have to be super accurate, but you do have to close your brackets on coordinates, people. What I just did. Because I'm looking at some of the graphs I marked on the chapter 7 test. But I think sometimes we get overwhelmed with the math that we forget to do the little stuff. Okay, so let's draw in our reference triangle. Where's theta reference? Theta reference is right there. We know the base of our triangle is going to be negative 5. We know the depth is negative 12. What do we need? We need the hypotenuse, right? The hip. You can do it in your head. And I told you guys already what this was. 13. It's a Pythagorean triple. I told them about it. They listened to me. Or they're just really fast at doing the math in their head and nobody listens to me.
What's the next best Pythagorean?
Those are the two that I know that I use the most. Those are the ones. Okay, so now we're doing the exact values. So all we're doing are the ratios. So sine theta is what? Opposite over hypotenuse. Well, where's my opposite side? Okay, all right. I guess I should have put my right angle in there. So if you're still struggling with how I'm pulling these numbers out, I would definitely make sure that all my sides are labeled. Because, I mean, you did learn it in grade 10, and grade 10 could be a million years ago now. So,
Say 10 is
a million years ago. Hey, what trig ratio is positive in quadrant 3? T. So tangent. So you guys know in your head that when you do the trig ratios, that tangent should be positive. So if you get a negative for your tangent, you know you've done something wrong. It's just a quick way to check. This is adjacent over hypotenuse. So -5 over 13. Tan is going to be 12 over 5. And then I'm going to get rid of those negatives, right? Make sure they're clearly erased. Some of you aren't great at erasing everything and I get confused.
We could just rewrite it.
You could rewrite it. That would be my preference. Can I ask you a question? Look at your page. Did you drop your theta anywhere? Yay, I'm so proud of you guys.
Just didn't write it enough.
Oh, I don't know if we can do this one. Cos of 135.
That seems complicated.
Well, let's find the reference angle. Let's not do this. Let's find the reference angle.
So we just,
Well, why can't we do?
This is an exact value off the unit circle, and you would have to know your trig ratios based on a unit circle, which we ain't got time for. I mean, I can do it. Go away. What's the reference angle?
45.
Okay, where is 135? What quadrant is 135 in? It's in quadrant 2. So we know that the angle in standard position, so starting from positive x going to the terminal arm, is 135 degrees. And I'm asking you to find theta reference.
So it'd be 180 minus 135.
Yes,
it's 45, right?
it's 45 degrees. So we used our rules. Now I'm just going to hop up to the rule here for a second. So the rule is theta equals 180 minus theta reference. And you guys did the math. You rearranged it in your head. You didn't even need the formula and you knew intrinsically what to do. So don't get caught up in using the formulas if they don't make sense to you, because they're just there to make it a little bit more fun. I don't know. 135 equals 180 minus theta reference. If I were to solve this algebraically, minus 180 from both sides, I'm left with a negative 45 equals a negative theta r. Divide by -1, divide by -1. Theta r is 45 degrees. So you can do it algebraically, but you guys intrinsically knew what to do, so just do it. Don't get caught up in the math. Sometimes the formulas are helpful when you don't know what to do, but you knew what to do with the math, so trust your math. Okay, we good? All right. Okay, this question will be on your test and quiz. Example numero 3. Okay? You guys can do that, right? No problem at all. Okay, where are you?
Third quadrant.
Third quadrant.
This guy,
Yep.
isn't like third quadrant supposed to be negative 10 or always positive 10?
It's a positive 10, right? So we know that in the quadrant 3. Now, why did I have to tell you quadrant 3?
So you knew which one was positive and negatives in our head.
Right, because cosine is positive in 2 places.
And
Where is it positive?
1 and
1 and
2.
4. Okay, so that means it's negative in 2 and 3. So that's why I had to tell you what quadrant you were in, because there really is 2 possibilities. You could be functioning in quadrant 2 or you could be functioning in quadrant 3. Does that make sense to everybody? So cosine is negative in 2 places. So I had to tell you in the question where you were. Okay, so you're in quadrant 3. This is exciting. Okay, so what I'm going to do is I'm going to draw my triangle in. I know I'm in quadrant 3. Okay, all right, this is good. This is good, everybody. I'm in quadrant 3. This is exciting. What do we know about the ratio of cosine?
Is adjacent and the hypotenuse.
Adjacent and hypotenuse.
Oh, that's smart.
What do we know about the hypotenuse? It's 4, but what do we know about hypotenuses in general?
It's always positive.
Always positive. So what's negative? Negative 3. So do you see how I pulled that information? That's right there on the page.
It makes sense because we're in the negative x value and the base is negative.
Exactly. What do we anticipate our y value to be?
Negative.
You're in quadrant 3. What's your y value? Negative. So let's use Pythagorean theorem to solve for our missing side. So I'm going to have, no, it's not.
It's 7, right?
You crazy kids. I got negative 3 squared plus b squared equals 4 squared. Because remember that c is always your hypotenuse.
Does it matter if you pick B for
No,
your negative?
it does not.
No.
Okay.
So now we're going to subtract 9 from both sides. Oh,
And whatever the ratio is.
I got to move over here, guys. So b squared is equal to 7. So it's root 7. But is it a positive root 7? Where are you on the coordinate plane? You're in quadrant 3. And what do we know about the y values in quadrant 3? They're negative. So the math with this isn't hard, but there's all these layers that you got to remember. And you guys know that when you square root a number, you can have positive numbers and you can have negative numbers. So really, this is going to be negative root 7. The negative has to be outside of it because you can't take the square root of a negative 7. So it's negative root 7. Negative root 7. So now we got to do the sine, cos, tan. So really, what do we need? We need the sine and the tangent because I already have the cos. Right? So we're going to do sine theta is equal to the opposite side, which is negative root 7 over 4. And tan theta, which is negative root 7 over negative 3. But am I going to leave it like that? No.
Get rid of the negatives.
I'm going to get rid of the negatives. And we know that tan should be positive in quadrant 3. So do you see how the cast rule helps us make decisions? Knowing where we are on the coordinate plane will help know if our x's and y's are positive, negative. This will be a question on your test and on your quiz. And probably on the exam.
Do you have like an exam review?
Yep.
Okay. Because I thought I'd have to like look through all my notes and remember.
Oh, you're going to have to remember everything. Yes.
Well, like after review, that's the easiest.
Do you give us
so.
a review of what patients grade?
Yeah, I think Cam and Madison had asked for that, so we'll try to get one put together for you before the Christmas holidays.
The majority of the year we work with quadratics. You just have to remember the different types of quadratics.
True, quadratics is a huge part of your.
Even if it's
All right, this is also going to be on your test and quiz, and these are my favorites. Okay, so you guys have lived in a world of one answer solutions. Not anymore. So now you've got 2 answer solutions. We just talked about this. So where would you guys agree that this is a positive number? 0.5 is a positive number? Yes? Okay, so where on the coordinate plane is sine positive?
1
Quadrant 1.
and 2. So it's number 1 and 2.
Okay, so how many answers am I going to have? So now you're dealing with all four quadrants. You're not looking at just, oh, here's a little pretty triangle. You're looking at all four quadrants. And this is the beginning of the unit circle for grade 12. So if you've got a good understanding of this, this is a really, really good foundation for jumping into the unit circle. Okay, so let's solve. Let's do quadrant 1 first. Okay, so in quadrant 1, that's just theta reference equals theta, so we can just go ahead and solve. So I'm going to do theta. That's a theta.
Oh, you put a 1
I put a 1. Why did I put a 1? Because I'm in quadrant 1. So I'm just going to go ahead and solve. Old school. Like, you know, grade 10, back in the day. So this, ooh, sorry, this should be sine negative 1 up here. So this is where I'm doing my second function. So second function, sine 0.5. Make sure your calculator is in degrees.
Is it
30 degrees.
Oh, it's in the first quadrant, right? We're doing number 1.
Okay, so in quadrant 1, I'm just solving it like old school. Okay? Quadrant 2, I don't have to do any math. I'm just going to go back to my rules. Meh. Meh. Oh, if you're in, yeah, make sure you're in degrees because that will mess you up. Okay, so now to solve for quadrant 2, I'm going to use my rules. I'm going to use my rule from quadrant 2. Okay? What's my reference angle? 30. So we're going to have quadrant 2 is 180 minus 30 degrees. So quadrant 2 is 150. You need both of these answers, ladies and gentlemen, to get full marks.
So how do you know 30 is the reference angle?
Yeah.
Okay, let's go back to our rules. In quadrant 1, theta is equal to theta reference. So you're always solving for quadrant 1. And that is your reference angle. Okay? All right, this is exciting. Aren't you guys excited? You're learning so much new stuff.
So it's gonna get, like in any other quadrant, we solve for quadrant 1 to get
Yeah. Yeah, exactly. Okay. Okay, guys, we got to get through this. So let's just do a couple more examples and see if it helps. Okay. All right, so cosine. Cosine, my ratio is negative this time. So what quadrants am I in? So this is going to tell me my answers in quadrant 2 and quadrant 3. So if you're dealing with a negative, you're going to drop the negative. The negative we just used to tell us where we are. Drop negative, solve, and solve as if it's in quadrant 1. Does that make sense to everybody? So the negative just tells us where we are on the coordinate plane. Now I need you guys to solve this one. So you drop the negative, so cos theta is equal to a positive root 3 over 2. Okay? Solve like... Then we just do it. We just do it in our calculators. Just do the math. So theta is going to be equal to, and this is actually going to be theta reference now because it's in quadrant 1. So, what? What am I doing?
Wait.
Okay. You told me to wait. What's the question behind the wait? Never mind. Okay.
Like, why did you go one beside the first question? And that was
I'm sorry, Danica, I can't hear what you're saying. Why did I put a 1, like theta 1 here?
yeah.
Because my answers were in quadrant 1 and quadrant 2. So when I do my answers, I'm going to put theta 2 and theta 3. I do that just to keep myself organized. You don't have to do that. Because, what did I drop? I drop my negative sign. So that automatically moves me to quadrant 1. Neither of my answers are in quadrant 1. So that's a theta reference. Because you need to solve for it like it's in quadrant 1 first, and then I'm going to use my rules to solve for quadrant 2 and 3. Okay? Okay, just ride the wave, people. So I'm going to go second function cos root 3 divide by 2, 30 degrees. I'm guessing that you should probably put root 3 divided by 2 as a decimal first, and then do your... So, ladies and gentlemen, you probably should get your calculator out and try this one. This one's a difficult one. Try this and make sure you get root 30 degrees.
Do I need to put 1.7?
So you can do second function, Danica, on your calculator. Second function, and then do second negative sign, and it will take the answer from the... Did you get 30?
I got 30.11.
It's Did you use... Okay.
Wait.
Wait, like, please go through, like, what we press.
I don't know what you're saying, Megan, sorry.
Like, what we press, like,
Error.
Okay, are you guys all in degrees?
yeah, can we go through what we're like?
Okay. Are you using second function in your calculator? I think the biggest thing you guys are probably doing in your calculators is going root 3 divide by 2, and really what you got to do is you got to move your cursor outside of the root sign, because it's not 3 divided by 2 all under the root sign. It's root 3 divided by 2. I don't know. It's your calculator. I have no idea. So you got to try a couple of things. That's why we're trying it on our calculator. Okay, so, oh my goodness, guys. Whiny pantses, you'll be okay. It's a calculator. Try it a couple times. It doesn't, you have unlimited tries. That's the good thing.
If I get 3 wrong, my computer locks me out.
Oh my God.
Do we put negative equals?
No, there is no negative.
Or, no, I didn't mean to say
There is no negative.
I don't know why I said
Okay.
I meant to say, like, we put, like,
Oh, I got it.
root 3 equals divided by 2? Or root 3 divided by 2? Just
Root 3 divided by 2.
3. Okay.
Holy man.
Oh, okay, got it.
How do you
Yeah,
get
Okay.
it so the 2's not under 30 cents?
Just take your cursor, which is this button up here, and just move it to the outside.
yeah.
Okay, I'm trying to do this. Sorry.
Yeah.
How many questions would a question, how many marks would a question like this be worth? Like 2?
I got it.
Yes.
Okay, so it's like
Yeah.
20 easy ones.
Did you get it? Yay.
I did not.
Oh my goodness, you. Are you in degrees? What did I say? First thing you gotta do is check to see if you're in degrees. So hit your mode button. Okay, you're in degrees. Just put it there. Okay, root 3. Close your brackets. Divided by 2. Close your bracket again, right? Because you gotta close your bracket every time. Okay. All right, now that we've all had our mental breakdowns. Okay, so because I dropped the negative, solve it like it's in quadrant 1, and that's your reference angle. This is my theta. Okay, let's draw the picture. Where are you? Cos is negative. We don't know. We're in one of two places. We are in quadrant 2, so we're either here, and my reference angle would be there, or we're in quadrant 3, and my reference angle would be there. So we're solving for both of those. So the rule for quadrant 2 is 180 minus theta reference. So 150. And don't forget your degree sign.
It can go over 180, right? If
Not in quadrant 2.
quadrant 3.
Yes. So in quadrant,
Can I just put
The next one is 210.
yeah, you totally can.
So 180 plus 30 equals 210, right? That's not
I love how we're all at different places and everybody's just like, ah!
We did the next one, see if I got it right.
Okay, I've got 8 minutes to finish this.
Can you do it?
I hope so.
You just need to wait a couple minutes and
Okay.
you're fine.
All right. Okay. So did you guys get your two answers, 150 and 210? You need both of those. This reference angle, oh, I love erasable pens when I make a mistake, is not an answer. It helps you find your two answers. Your answers for where cos is negative are in quadrant 2 and quadrant 3. Okay?
If you circle it like an answer, would you get 3 marks?
No. No. But I'm just telling you that that is not a solution. Your solutions are here and here.
Yeah.
Okay. Part C. Where are my answers?
2 and 3 now.
2 and 3 again. Is it helpful to write down where they are?
Yes.
You decide that. That's up. Drop the negative. So step 1, drop negative. So you were solving for cos theta. This is now your reference angle because we dropped the negative. Okay, you're going to put that into your calculator. This time it's not a root sign, so to be nice and easy, you just need to put that decimal in there.
Isn't it? I thought you put the -1. I think it's like,
Oh, you do second function. What I said is you don't put this negative in there.
what?
I don't know, Danica. You just do your math and see if you get the same as me. Anytime you're solving for an angle, you use your second function button.
So why would you put the -1?
What's the answer?
I haven't even written that step yet, my dear. Oftentimes I don't write this step. So we're gonna round to the nearest whole degree. Okay, is that my answer? No. So what we need to do is we need to use our rules. So in quadrant 2, 180 minus 48 equals 132. And in quadrant 3, it's going to be 180 plus 48. So that's going to be 228. So these are my two answers. Okay. Last example. We've got 5 minutes left of class. I'm going to get you guys to do it. Okay? You guys do it. I'm going to move it, and I'm going to do it at the same time, and we're going to see if we can do it together. What?
Yeah.
No.
No, it's 2 and 4.
No.
Percent?
Oh,
Yes, it's 2 and 4.
Isn't it 1 and 2? It's 1 and 2.
Guys, does it have a positive or a negative in front of it? So cast rule always tells me where it's positive.
Which is 3 and 1.
No. Holy Hannah, guys. Yes. Okay. The cast rule tells us where it's positive.
Wait, C-A-S. Oh, never mind. It's 3 and 4.
It's 2 and 4.
Cast.
What?
It's negative and 2.
What?
Oh, no.
Okay, so where is sign positive?
1 and 2.
1 and 2. So therefore, we're looking for where sign is negative. So it's going to be in 3 and 4. Not 1 and 4, not 2 and 4. That was a lot. That was intense. You guys were like angry about it?
it's on the tape.
Like it just angry. Like it immediately went to anger.
Because you feel challenged.
Oh, goodness.
So if you drop the negative,
I wish I had
Yep.
This is when we should have cut the knife. Oh, I'm just reading. I'm not proud. Let me see what
Danika's crying. For those of you at home, Danika's crying if you can't hear it. It's fun. We're going to round to the nearest whole degree, everybody.
what is the whole degree? 'Cause I don't know how to-
It's
this is a long lesson. I said it was going to be a short lesson. I was like, yeah, we're going to blow through this, no problem. I didn't realize we were going to be so angry. Can I throw up my answers?
No,
You don't even have a calculator.
I know, that's my condition. So don't throw them off, I'm trying to do it mentally. That's,
Do it mentally then.
I don't know. Just start throwing random answers until it looks right.
Okay, here's what I got.
Not too lazy at calculating. Yeah.
It's easier. I got like 53
Very close then, mentally.
Right, and we said that we were going to round to the nearest whole degree.
Oh,